Hello and welcome back to another video. In this problem, we're asked to prove that the equation has at least one real root. We have arctan of x is equal to 1 minus x. So our first step is to subtract 1 and add x to both sides. What this is going to give us is 0 is equal to arctan of x minus 1 plus x. And we're going to call this f of x. And for f of x to have a real root, there must be a value of x such that f of x equals 0. And we're going to use the fact that we have a inverse trigonometric function and a polynomial. And from theorem 7, we know that both of these functions are continuous over their domains, and for these in particular, they are continuous over all real numbers, because their domain is all real numbers. And by theorem 4, we can say that their subtraction is also going to be continuous over all real numbers because the parts are. So what we can say is that f of x is continuous over all real numbers. So we can use the intermediate values theorem, which states that since f of x is continuous over all real numbers, and now we have to find two different values of f of x. So let's do f of 0 and f of 1. Right, and if these particular points didn't work, you try other points. F of 0 equals arctan of 0 minus 1 plus 0, right, plugging in 0 for x. This is going to give you -1, and f of 1 is arctan of 1 minus 1 plus 1, which is roughly 0.79. Since f of 0 is less than 0, and f of 1 is greater than 0, for this continuous function, there exists a value c such that f of c equals 0. And we know that c is between 0 and 1. How do we know this? We have a continuous function here, and we know that at 0, it's a negative value, and at 1, it's a positive value. So for this to be true for a continuous function, it would have to cross the x-axis at some point, and therefore has a root. Therefore, the equation has a root. In part B, we're asked to use a graphing device to find the root correct to 3 decimal places. And so if we have graphed this function, I have pulled it up in Desmos, all we have to do is to zoom in a little bit and see that the intersection point is right here. Let's zoom in. We want it correct to 3 decimal points. And therefore, we can say that it is equal to 0.5203, rounding to 3 decimal places. X equals 0.52.